Woohoo! We're live. This is Math 60, Intermediate Algebra, Section 1.4, and we're going to get started on what you probably think of as algebra. Yay! And of course, because it's me, we're going to do it really, really slowly and carefully. And the reason for this is that I think, although frequently people leave the logic till later, I think it's important for you to know what the rules are. Why are we allowed to do algebra the way we do it? I know that, my hungry squirrel is wondering, like, yeah, how do we do this? What does all of this mean? What is the meaning of algebra? Why are we even here? Well, the answer is that math is the most important thing on the planet, and it is the only pure thought you will ever have in your head, little squirrel. And the squirrel's like, okay, so let's go ahead and get started. I want to start with properties. Now, you don't have to memorize these, but again, if you know them, it will make other things make more sense. You'll be able to make more thoughtful decisions. You'll be able to see when you make errors more easily. Those of you going on to calculus and beyond, you may want to memorize these just so you'll have the vocabulary in your head to be able to talk about the math. So, properties of real numbers. These are things that I think you already know, but we actually sat down and wrote them down. Well, I didn't. This was a long time ago. Even though I was born in the 1700s, people were talking about this long before I was around. So the commutative property of addition sounds like a bunch of gobbledygook, but I want to point out that it has the word commute. And it doesn't have the full commute because the E disappeared, but it has commute, but you know what I mean. So commuting means to move around, right? Especially like on your way to work or to home or somewhere else, to school. So what does it mean for numbers? A plus B equals B plus A. So it's a property of addition, which means we're using addition. And it just says we can change the order of addition. So in other words, 3 plus 4 is 7, but 4 plus 3 is also 7. Oh, look at that. 3 plus 4 is equal to 4 plus 3. And this is something that, believe it or not, if you were watching Sesame Street or other, wholesome educational programming for preschoolers, and they move dogs around when you're counting, or you're counting cats and they move around, or pizzas, this is one of the concepts they were trying to get to. And that is that addition is really actually very nice to us, although frequently also is very evil. So it's a complicated, it walks a complicated line. So 3 plus 4 equals 4 plus 3, or I could also write x plus y equals y plus x. So I can do the same thing with variables, not just constants. Does it work for subtraction? Oh my gosh, wouldn't it be awesome if it worked for subtraction? So let me tell you a story. I had $100 in the bank and I withdrew 20. How much is left? 100 minus 20 is 80. Okay. Another story. I have $20 in the bank and I say, can I withdraw $100? And the bank's like, sure, that's no problem. No, that's not what happens. They'd be like, what? No. Not equal. So this property does not actually work for subtraction, just addition. Okay, next up, I'm going to try it for multiplication. The commutative property, and again, commutative means to change. So this is A times B. Notice this is B times A. So you actually flip the order you write them in. Fun fact, some parts of the world say commutative, which is very fancy. So if you want to be fancy, commutative property of multiplication. Oh, so fancy. So let's look at an example. I like my 3 and my 4, so let me try that. 3 times 4 is, you got it, 12. 4 times 3 is 12. Oh my gosh, look at that. 3 times 4 equals 4 times 3. Which is pretty cool because 3 times 4, depending on how you're looking at multiplication, could represent a situation that's completely different from this. This could be 3 groups of 4 things. This could be 4 groups of 3 things, right? So 3 groups of 4 things. Let me see if I can do this really fast. There's 4, there's 4, there's 4. Pardon me. 4 groups of 3 things looks like this. So depending on how you look at multiplication, you could be describing 2 different situations. But the great thing about multiplication, let me darken these up so you know that they're there, they don't go hiding. Multiplication can be written in either order, which is pretty cool. And of course, xy, you can rewrite as yx if that helps. Does it work for division? Well, let's try switching the order. I'm not going to do 3 and 4 because, fractions, right? Am I right? 6 divided by 3. 6 divided by 3 is 2. 3. What? I didn't make a mistake. Look over there. Is that a pterodactyl flying by? Yeah, okay, I didn't think so. 3 divided by 6. So if I flip the order, 3 divided by 6 is this one, which is 1/2. Not equal. So no. So it's interesting because I spoke in a past video about the fact that addition and subtraction really boil down to the same thing. Multiplication and division really boil down to the same thing, which is true. That's why in order of operations, these two, addition and subtraction, and these two, multiplication and division, each share a line. They share importance, but they are not exactly the same thing. The way that subtraction works and the way that division works means that you can't just flip the problem. You have to preserve your order. You have to start with the one and follow with the next. You can't just flip them and get the same answer. So good things to know. So I've got the commutative property of addition, the commutative property of multiplication. I know you guys are very excited. You're like, whoa, what's behind the, wow, look at all this cool stuff we're learning today. I know what's behind the white sheet. The associative property of addition, which I learned from folks with accents. So I do say the associative, and that is very fancy and maybe a little too formal. So I think most people, at least in California, would call this associative property of addition. And I apologize, I say it kind of strangely. Notice what's really happening. This is a little different. We've got addition, so we got all the pluses, but suddenly what's the difference? Well, right off the bat, I see it's not just A and B, it's A, B, and C. Suddenly this is a much bigger thing. And then if you're very careful and look at it, you see A, B, and C are actually written in the same order on both sides of the equation. Let me pull this back. When we were talking about the commutative property of addition, A plus B, A was written first, B second, and then on the other side of the equal sign, B comes first and then A. But in this one, they're written in the same order, so what's different? Well, the different is the grouping symbols. That's the association. So this is like, these two are best friends. So on the left, A plus B are best friends, so they go first. This gets added first, and then this gets added second. And on the right side, this gets added first, and this gets added second. So the associative property has to do with when we use grouping symbols. And basically what it's saying, and I know sometimes you look at these, and I look at these in math, and you're like, what are you really trying to tell me? What it's trying to say is if addition is the only operation involved, grouping symbols won't change the answer, which is pretty cool. So in other words, let's take a look. Now that I've taken all my space to write that out, let's look at 3 plus 4 plus 5. Okay, so what does this tell me? This tells me I have to do 3 plus 4, so that's 7, plus 5. What's 7 plus 5? Well, that's 12. Okay, now what's the other way to write this? Remember that ABC, ABC. The numbers get written in exactly the same order. So it's 3 plus 4 plus 5. But in this case, 3 and 4 were inside the parentheses. Now we're going to put 4 and 5 inside the parentheses. So we're going to force ourselves to add that first. So this will be 3 plus, and in here 4 plus 5 is 9. 3 plus 9 is 12. So in other words, if you've got a whole bunch of numbers to add together, you actually don't have to worry about the order. You can add in any order. We can add the last two and then the first one, or we can add the first two and then the last one, your choice. There is also an associative property of multiplication. Check it, A, B, C, A, B, C. They're written in the same order, but there are grouping symbols. There are parentheses put in to force you to multiply in a certain order. So let's check. Let's see what we think about 3 times 4 times 5. Now, something to notice is when you put two constants together, two numbers together, you have to write the multiplication in between. You don't with letters because we know that the letters represent separate numbers. But if you put the 3 and the 4 together, it'll just look like the number 34. So, okay, so let's go ahead and multiply inside. I get 12 inside and 5 on the outside. Notice that secret multiplication, there's implicit multiplication. 12 times 5, I happen to know is 60. Versus 3 times 4 times 5. So I write them 3, 4, 5, 3, 4, 5, but the parentheses change. That means I do this one, 3 times the quantity 4 times 5. 4 times 5 is 20. And 3 times 20 is 60. Yay, yay. Now, I should have written yay, it works. So, does it mean if I give you a single example, I've given you a single example in each case, does that mean I've proven it? No. So, fun fact, I'm barefoot right now. I'm barefoot a lot of the time. If we were in class, I would be barefoot, believe it or not. Shoes and I just don't agree. I wish I could say it's an ancient curse. It's just because I'm very deeply clumsy. So, if I am barefoot right now, does that mean everyone is barefoot right now? And the answer is no. Finding one example does not say everything works that way. So when I'm writing out these examples for you, I'm just showing you, kind of giving you an example so you can sink your teeth into it and understand what's happening, see what's happening with all the moving parts. The actual proof of these is not something we're going to worry about. This is really just when we say something's a property, it's something that we're all going to think deeply about and go, yeah, okay, yeah, I agree. This seems to be happening. So these things are definitely happening. Do we have an associative property of subtraction or division? No, we really don't. And it's pretty fast to find out why. One more property, and this is one that you've studied before, but again, I think I want to remind you. Now, this is the one that gets used the most, so most people are familiar with this, but this is actually the fifth property, or the third, depending on your perspective. And so of all the properties, it's funny that the last one gets all the attention. The distributive property is also known as visiting the family. I went to a conference a billion years ago. There are conferences that are held twice a year, and people who teach math at the community college level get together and then tell each other how to be better math teachers, how to be better mathematicians, how to be better teachers in general. We have big conferences and celebrate teaching math. And one of these conferences, the person who was leading the session I was in said he did not use the term distributive property. He used the phrase visiting the family. And the way that it's used is if you have more than one, say, auntie, and they're spread out all across either the country or the world, you know that if you go to spend one holiday, say Arbor Day, with one auntie, the other aunties will all know. And they're going to expect you're going to visit them for other holidays, right? They keep track. They count these things. So in a similar way, if you've got B and C, B plus C inside, and A needs to visit, A better be sure that they go to see both B and C. A went to see B, A went to see C. See how that works? So if you've got A times the quantity B plus C, A goes to see B and A goes to see C. Now, one thing I will point out is there's something weird that happens, and it just has to do with the notation. On the left, in both cases, we've got a single A. Here, we've got A written twice. We do this in English all the time. So all the time I could say, today I have to go to the supermarket and I have to go to the cleaners. Shall we say that? I could also say, rather than saying I twice, I could say I have to go to the supermarket and the cleaners. I have to go to the supermarket and the cleaners. I have to go to the supermarket. I have to go to the cleaners. Mean exactly the same thing. It's just two different ways to phrase it. So let's look at an example. If I have 3 on the outside and 4 plus 5 inside, and you do not have to write the arrows, but I find that a lot of people, it helps to trigger the memory. So if writing the arrows helps, that's great. Do you know that you can also write the arrows on the bottom? Those are just notational for you. I'm going to write it out. It's 3 times 4 plus 3 times 5, which equals, let's see, 3 times 4. Let me use different colors here because I'm going to go horizontally. 3 times 4 is 12 plus 3 times 5 is 15. 12 plus 15 is 27. Okay, so then what if I actually multiplied this? What if I actually did this? What if I add inside the parentheses? Then I get 3 times 9 inside. 4 plus 5 is 9. 3 times 9 is 27. Ooh, it worked. Yay, I love it when math works. Yay. You should always celebrate when math works, because I got to be honest, the further you go in math, the more often it starts to get a little bit weird and maybe breaks some. So, woohoo, it worked. As long as you can add inside the parentheses, you will always have that choice. You can add inside or you can use the distributive property. Both ways will work. Now, the distributive property also has a subtraction form. So what would that look like? Well, if I have 4 minus 5 inside, again, I'm allowed to 3 times 4, 3 times 5. Just make sure, here I have my green. Just make sure that if you have a minus in the middle in the original, you need a minus in the middle in this one. Get 12 minus 15, which is -3. Now, what if I actually calculate inside, evaluate inside? So what if let me do orange because I did orange before. What if I do that? What is 4 minus 5? You got it. It's -1. What's 3 times -1? Woohoo, you guys are awesome. -3. Yeah, and you could say mashed potatoes to the screen too. I will tell you you're awesome, regardless of how you answer. Did you know, fun fact, no matter how much math you know, you're still awesome? It's truth. Yeah, it's hashtag science. I am a scientist. I know these things. I've studied many things and I know what the truth is. I've studied logic. You're still awesome, regardless of how much math you know or how well you do in classes. Still awesome. Okay, woohoo, these work. Yay. So we've got all 5 properties, which we're going to start using to quote unquote solve equations. So I'm going to peek over here. Do we have time? No. Okay. Sorry. I thought I would just push forward, but we just hit the 20-minute mark, and the rules are I'm going to try to keep it down to 20 minutes because 20 minutes is when people start to go like, I would like some Doritos. So go get some Doritos if you'd like, or, if you hate Doritos, don't get them because that would be miserable. Math and Doritos if you hate Doritos. Ugh. So go get a snack. Go get something, some fruit juice or maybe some water if you're trying to keep your sugar down. Awesome, awesome, awesome. Or some La Croix or whatever, get some snacks, get something to drink, and then meet me back here, right here, because I'm going to go ahead and we're going to start simplifying some expressions. I know, it's very exciting. Okay, guys, math on.